Okay, so welcome all. I'm Pintu Kumar. I'm a PhD scholar at IUR Bombay, and I'll one of the TAs for this course, Basic Linear Algebra. Okay, basically aimed at UG students, but master students can also take it to clear their concepts. So this lecture today is gonna be based on first week content. Okay, and the topics that I intend to cover is systems of linear equation, and here I'll also try to cover some basics of matrix, what is matrix, matrix multiplication, and how to transform system of linear equation into matrix, and then solve them. Okay. So uh, here I have included two references that I find are useful for just this week's content. I'll try to include in the next week also whatever I find is useful. So first book is Linear Algebra and its Application by David Seeley. So chapter 1 and 2 is useful over here, but some portion of 2 is useful, some portion of 2 might be new, what is not covered, but it is good to look if you want to have a look. Second book is Linear Algebra and its Application by Professor Gilbert Stein. I think most of you might know Professor Gilbert Stein for various reasons. And chapter 1 over here is also useful. Yeah, MIT. So yeah. So one more thing, like if you want to ask any doubt anywhere, you can either type it in the chat box or you can just unmute yourself and speak anytime you want. Okay. So these are the two references that I found useful. Questions, a lot of questions are available in this first book by David Seeley. You can also practice from there. Okay. Probably not this week, but yeah, but this week's content is easy, but you can. Okay, so first of all, let's look at what is linear equation. Okay. So a linear equation is something of form ax1 plus bx2 and let's say some bn of xn is equal to some c. So what do we mean by linearity over here is that these variable terms that are appearing are just raised to the power 1 and are not multiplied with each other. This is what we mean by linear equation. So in linear algebra, we try to study these kind of equations. So for example, if we look at this equation, let's say 2x square plus 2 is equal to, let's say, 3. Then over here you can see that we have something raised to the power 2. So these kind of equations are not linear equations. Again, if you take another example, let's say this is 3xy plus 4x is equal to, let's say, 5. So here you can see that x and y are multiplied with each other. So these kind of equations also don't fall into category of linear equation. In linear equation, we will have only single variable associated with the coefficient, and they will be raised to the power maximum of up to the power 1. So either 0, that is your constant term, or power 1. So these kind of equations are something called as linear equations. Okay, all right. So what we want to do is we want to find a set of possible solution for our given equation. So let's say for example x plus y is equal to 1. We want to find all x and y's, okay, that satisfies our equation. Okay. So as I mentioned, this is not a class, but tutorial session. So I'll just begin with solving a problem. This you might have done in your schooling throughout, right? So here is a system of linear equation. So by system, I mean I have more than one linear equation that I want to be satisfied simultaneously. So we have a system of linear equation and I want to find the possible set of solution x, y, z. Okay. So can any one of you just, all of you would know, I know, but can any one of you tell me how should we proceed with this? Okay. See, what we try to do is, I'll talk about elimination method over here. Okay. In elimination method, what we try to do is we try to eliminate variables from these equations. Okay. We'll go into matrices a bit later. Right now, I'm just talking about how to generally deal, how used to solve in schooling. Okay. So let's say if we want to eliminate x from this equation, second equation and third equation, if we subtract first equation from second equation as well as the third equation, then we can eliminate x. Then how would our system equation look? Let's say we subtract first equation from second equation and third equation. So our first equation remain unchanged. Okay. Right. Yeah. And our second equations become 0x plus y plus z is equal to 3. Right? Now, our third equation becomes 0x plus 2y plus 2z is equal to 6. Okay. What can we do now? We want to eliminate something from here also. Okay, this is our aim. So if we now take, let's say we call this now first, second, and third. If we subtract 2 from 3, what we can get is, we can get a new set of equation, that is our x plus y plus z is equal to 4. Over here we can get our y plus z is equal to 3, and here we can get 0 plus 0. So this is 2 times of equation 2 is equal to 0. Okay. So we can get something like this. You can see that we have we have reduced this to 2 equation, and we have 3 variables to solve. So one of them like would be a free variable. This is what we call a free variable. So we have choice for this variable. Let's say we take z to be a, then what does our y become? Y becomes 3 minus a. Okay. And like now we can put this again back in equation 1 to obtain value of x. Probably this is what you have been doing in your schools. Some of you are master students also, but if most of you are bachelor student, you might have done this in schooling. Okay. But what if our number of variables is very large? How should we deal with it? That's where linear algebra comes handy. Okay. So what we do is we transform this kind of set of equations into matrix notation, and then we can use computers to solve our problem. Also, like if you have, let's say, 4 or 5 variables, sometime transforming it into matrix makes your work easier. Okay. So because this is the first week, I'll try to like uh, like there might be some people who are not very comfortable with matrix, so I'll try to clear the notation for you. So what is a matrix? So you have numbers like 1, 2, 3. Okay. So if you look at these things, they don't have any dimension or like shape. Okay. So they are just a point. Let's say if you have a number line, you can represent them via point. Even in 2 dimension, you can represent numbers by point. But yeah, but let's say we want to represent this equation via some data structure. What should we do? Okay. So there we talk about matrices. So what is a matrix? Matrix is a rectangular representation of data. Okay. What we have is, we have some rows, okay, and some column, and at every of these intersection we have some values. Okay. What do I mean is, so a matrix would be something of form, I'll just go here. So a matrix is something of form this. So we have one row, two rows, and 2 columns over here. And at intersection of every row and column, we have some values. This is how a matrix look like. Okay. So what is horizontal is known as a row. What is vertical is known as a column. Okay. Also, we can write size of a matrix as m cross n, where the first entry represents the number of rows in the matrix. Okay. And the second entry represents the number of column in the matrix. For example, in this matrix, we had size 2 cross 2. Okay. Now, let's say you want to write any arbitrary element of the array or this matrix. So, let's say this is Aij. So, in Aij, your first entry represents the row number. So, here this you can see that's A11. I think the color is not very great. Okay, let's see this one. Okay, this is A21 because it is in second row. Sorry, I think I disconnected. Am I audible now? Can someone confirm now? Is my screen visible and am I audible? Yeah, thank you. So I was saying that in an matrix, this horizontal thing is called as a row, and this vertical thing is called as a column. Okay. Now, how do we write any element in a matrix? So it is written by Aij, let's say. Then I is the row number for that element, and j is the column number for that element. So let's say this is our A21, then this 2 over here represents that it is in row 2, and 1 represents it is in row 1. Okay. So this is how we denote a matrix or an element of a matrix. So yeah, one more thing, like I thought that because this linear algebra is heavily used in many applications, and yeah, one thing I thought of including is that I'll include some small MATLAB commands in between, so that if you want to use MATLAB somewhere in future, so you are familiar with it. Okay. So yeah, so this is a MATLAB snippet that I've included. Let's say if you want to define a matrix in MATLAB, what you need to do is you just need to, like, if you want to assign a variable a to be a matrix, then you need to start this square bracket. Okay. Start writing the elements. Let's say this is 1, 2, separated by commas. Okay. 3. So whatever you are separating by comma, that thing will be written in one row. Okay. So this would appear as 1, 2, 3. Next is you can use a semicolon. The moment you use a semicolon, the things go to the next row. Okay. Then you can write 4, 5, 6, and it would appear as 4, 5, 6. Again a semicolon. Then if you write 7 space 8 space 9, then it appears as 7, 8, 9. Okay. So this is, so you can either use comma or you can use a space. MATLAB understands it to be the same. Okay, so if you want to create some matrix in MATLAB, so this is a small matrix. You like if it would have been a like 10 cross 10 matrix and you wanted inverse of this matrix, then it won't be possible for you to compute via hand. And if you just did something like a to the power minus 1, in MATLAB it would have computed inverse for you for any size. So then it becomes useful. Okay. Okay. Next thing is what is a column vector? Okay. So a vector you can say is a like a one-dimensional matrix. Okay. So this is a column vector. What is a column vector? In column vector, we have only one column. Okay, so this is just one column that we have. These kind of matrices are called as column vectors. Okay, its size is some n cross 1. Over here, its size would be 1, 2, 3, 4, 4 cross 1. Okay, so this is something how a column vectors look. So yeah, in while we are solving a system of linear equation, we'll encounter these kind of vectors also. Okay. Something similar is a row vector where we have only one row. We have many columns, but we have only one row. Okay, so this is how a row vector would look like. Right now, I'm going through just the basics of matrix because that was what was covered in the lectures also. From next week onwards, I think you would enjoy these sessions a bit more when we have some real learning. Okay, so what do we mean by transpose of a matrix? But these things are also important. Without these things, you won't be able to understand the later part. Now, next thing is what is a transpose of a matrix? Let's say we have a matrix like this. Let's take simple matrix. If you make your first row, sorry, the first column to be the first row of new matrix, okay, first column to be first row of your matrix, second column to be the second row of the matrix, then whatever matrix you obtain is known as the transpose of this matrix. So let's make it. So our first column is made the first row of the matrix. This is 1, 4, 7. Okay, then this would be 2, 5, 8. Then this is 3, 6, 9. So this, if this is represented by A, then this would be represented by A transpose. So it is denoted by A transpose. In some book, you would also see a symbol like this as A transpose. These two means that this is transpose. Okay. Probably I'll take one more example. This is not a very difficult thing, but yeah. Let's say we have a column vector like 1, 2, 3. What would its transpose look like? This transpose would look like this 1, 2, 3. Okay. So the first column was made into a first row. Okay. Now for MATLAB thing, if you have some matrix is same as above, then you can just write A dash and it would become A transpose for you. Okay. In MATLAB, it's that easy. Okay. I think I can zoom in this. Yeah, I have just made a dash and it gave me the transpose of the earlier matrix. Any doubts so far so that we can proceed? Anything? Probably no doubts still here, but anything you want to ask? Okay. So next is what is a symmetric and skew symmetric matrix? Okay. Now I'll define these two things. First is symmetric matrix. What do we mean by symmetric matrix? A matrix A is called symmetric if A transpose is equal to A. So if we transpose the matrix and we get the same matrix, then it is called a symmetric matrix. Okay. And what is a skew symmetric matrix? Is skew symmetric matrix if A transpose equal to minus A. Now, see, two matrices, when do we call two matrices to be equal is, first of all, they should be of same size. Okay, if they are of same size and their corresponding entries match. So if it is 1, this entry should also be 1. Okay, so if this entry is, let's say, A, then this entry should also be A. If they are of same size and their corresponding entries match, then these two matrices are called equal matrices. Okay, so here when we say that these two are equal, so A transpose and A is of same size. Okay, so let's say if A was m cross n, then A transpose would be n cross m, because we made the row into a column. Okay, so if these two are of same size, this means these matrices are like have same number of row and column, and these kind of matrices are called square matrix. So these are of size, let's say 2 cross 3 cross 3 or 4 cross 4. So they have same number of rows and columns. And in skew symmetric matrix, uh, like if you want this to be the negative of A, if you see the diagonal entries, so if you have a matrix like this, 1, 2, 3, 4, 5, 6, 7, 8, 9, these entries, this 1, 5, and 9, these entries are something that are called as diagonal entries. Okay. So whenever you take transpose of a matrix, these diagonal entries do not change; they remain intact. Okay. So like if we solve this example over here, if you see, their diagonal entries are exactly the same, 159. Here also they are 159. Okay. So the diagonal entry don't change. So in a skew symmetric matrix, if you want this diagonal entry to be the negative, let's say my first element is A. Okay. So if you want A to be minus A, what does this mean? That only possibility is that A should be 0. Okay. So in a skew symmetric matrix, all our diagonal entries are always 0. Okay. So here I have included an example. Let's try to solve this. We'll just try to look and see if they are symmetric or not. So we have to answer two things: determine whether or not each of the following matrix is symmetric or skew symmetric. So we have to check whether they are symmetric and whether they are skew symmetric. So for the first one, what do you think? Whether it is symmetric or not? So yeah, you can participate. Otherwise, this won't be any beneficial at all. So see, this first row is 5 minus 7, 1. And if we transpose it, that would become our first column, 5 minus 7, 1. Second row is minus 7, 8, 2. Third row is 1, 2, minus 4. Are these matrices same? Yeah, these two are same. Sahil, you need not raise hand. You can just unmute and speak anytime you want. That's fine. You have anything to say, you can just unmute and say. I think you raised it by mistake. Okay. So yeah, this matrix is a symmetric matrix. Okay. And it is not, this A transpose is not at all equal to minus A. So this is not skew symmetric. Okay. And it is symmetric matrix. Now let's look at the second example. So you see, this first row should come as first column. So if our first row and first column are same, then it would be symmetric. See, the first row is negative of our first column. Okay, now let's verify the second row again is negative of second column. Third column is negative of our third row. So this is a skew symmetric matrix. Now for the third case, what do you guys think? Yeah, this is not a square matrix only. So like if we take A transpose, its size right now is 2 cross 3, 2 rows, 3 columns. then A transpose would be of size 3 cross 2. So we can't compare whether it's like we can compare that it is not equal. But yeah, so this is not a square matrix, so it's neither skew symmetric nor it is symmetric matrix. Okay. So this was the example. So yeah, here is another example. That you have to find x so that this matrix becomes a symmetric matrix. Okay. So how would you do that? You want your first row to be same as your first column. Okay. This is how you will get symmetric, because if you will convert your first row as your first column, then this should be same, right? So then your x plus 2 and 2x minus 3 should be same. So x plus 2 is equal to 2x minus 3. What does this mean? What is x equal to? If you take x this side and 3 this side, what would it give? Yeah, x is 5. Okay. So we are going pretty slow today. Okay. Next topic that I thought what I would cover is matrix addition. So let's say you have a matrix A. Now you want to add it with another matrix B. Okay. Then how do we do the addition? So let's say you have A11 over here. Now I'll switch to some generic notations. A12 over here, A13 over here. This is A21, A22, A23. And you want to add it to B11, B12, B13, B21, B22, B23. Okay. So first of all, their sides need to be same. So they need to be of same size so that we can add them. Then what happens next is your first element gets added to the first element and you obtain the first element of the summation matrix. So this first entry would be A11 plus B11. Next one would be A12 plus B12. And you can fill rest of the entries so on. Okay, this is how we add two matrices. Next is your, here is an example. So subtract also you can do similarly. One thing is that how do we do scalar multiplication? Let's say this is my matrix 1, 2, 3, 4. We want to multiply it with some number 4. Then every entry of the matrix get multiplied by that number. This is how we do scalar multiplication. So this would become 4, 8, 12 and 16, something like this. Okay. So we have two tiny examples over here. Like if you want to add a plus b, what are a plus b would be? This would be 1 plus 3, that is 4. Minus 2 plus 0 would be minus 2. 3 plus 2 would be 5. Again, this would be minus 3. This is 6. And this would be 2. You can do similar computations over here also. Any doubt in matrix addition? I don't think there should be, but any doubt still. Okay. So here is a MATLAB snippet. If you want to add two matrices, A I already defined the way I told you. I have defined a matrix B to be 1s 3, 3. What does this mean is that this would define a matrix of size 3 cross 3 where all the entries are 1. Okay. So this is what is meant by 1s 3, 3. So I have defined a matrix of size 3 cross 3 and I've added it to the existing matrix. To add, you just need to write something like this. A plus B, it would give you the answer. Okay. Scalar multiplication I've already covered. For MATLAB, you just need to write 2 into A. Okay. Let's say you want to multiply by 2 or any other constant, you just need to write that, multiply it by that. Okay. Now we will look at matrix multiplication. Like if anybody of you don't know, probably this would be a good idea to learn. See, first of all, let's say we have a matrix A of size M cross N, okay, and we have a matrix B of size P cross Q, okay. So this is M cross N, this is P cross Q. Then the matrix A and B can be multiplied only if your N and P are equal. Okay, so N is equal to P, that is the number of columns in A is equal to the number of rows in B. If this thing holds, then only you can multiply two matrices. One thing I forgot to mention is that if you want to ask anything in Hindi, that is also fine for this session, because this won't be evaluated or anything. So you can ask in Hindi also if you are stuck somewhere or you want to ask something. Yeah. So yeah, if my N is equal to P, then only I can multiply two matrices. Okay. This is one thing. So let's check this in case of this matrix. So its size is 3 cross 3. This one is 3 rows, 1, 2, 3, 3 rows. This is 3 cross 1. So this thing matches. That's why I can multiply these two matrices. Okay. Now let's see how will we multiply this matrix. Okay. First of all, wait, yeah, we take the first row. So wait, yeah. So what we will do is, to obtain the first entry, we'll take the first row, multiply it with the first column. This will give us the first entry. Okay. How do we multiply? Let's see. So what we do is, we take the first entry of this row. So we want to multiply this row, right, with this column. Okay. We take the first entry, we multiply it with the first entry. So what we get? 1 into 1. Okay. Then we put a summation sign, that is plus. Then we take the second entry and multiply it with the second entry. So this is 0 into 2. Okay. Then we take the third entry and we multiply it with the third entry. That is 1 into 3. What did we get? 1 plus 0 plus 3. So this is 4. Okay. Similarly, now to get the second entry, what we will do is, we will do the same thing. So 0 into 1 is 0, plus 1 into 2 is 2, plus 1 into 3 is 5. So this entry is 5. Okay. Now for the third thing, we have 1 into 1 as 1, plus 1 into 2, this gets us 3, 0 into 3 is 0. So this is 3. So what we do get? We will get 4, 5 and 3 as the answer. Was this multiplication clear? Which one is 3? In the first row it is 3. Why would the, see, the first one gets multiplied 1 into 1, this gives us 1, then 0 by 2 gives us 0, and 1 into 3 gives us 3, 3 plus 1 is 4. No, it's not -1. If it is looking like -1, I'm sorry for that. It is just 1. Nothing negative is over here. So, oh, okay. So I denoted this arrow by this color over here I wanted, but yeah, this is not minus. Sorry. Okay, this is not minus. So like, if matrix multiplication is not clear, I can spend more time over here. For anyone, if you want to ask in Hindi or English or anything, you can please ask. You can even type in the chat box. I'll wait for 1 minute. I know that it is clear for you, but for others also. Because matrix multiplication would be used throughout the course. If there is any doubt in this, I know this is very basic stuff, but if you have any doubt, if somebody has any doubt, you can please ask right now. Okay, so I'll take one more example. Right now we had only one column. Let's take this only. This is 0, 1, 1, and extend, sorry for my handwriting, and let's extend this right hand side to be a 3 cross 2 matrix. This is 3 cross 3, this is 3 cross 2. Again, the sides are compatible, so we can multiply these two matrices. First first column we already obtained 4, 5, 3. Now to obtain the second one, we'll do the same thing. We'll multiply the first row with the second column. Okay, so we get 1 into 4 plus 0 plus 6. This gives us 10. Then again 11 and then 9. Okay, so to get let's say our AB is equal to C, then to get Cij, we multiply ith row of A with jth column of B. This multiplication, I mean, by multiplication over here, I mean that we are multiplying first element with the first and then summing it second with the second, not in the matrix multiplication sense of multiplication. Then also it would be correct, but yeah, this is what I need. Okay. Now coming to the MATLAB thing, you just need to write A multiplied by B to obtain your answer. Here I have tried two things. One is A into B, another is B into A. You can see that A into B is not equal to B into A. Okay. So this matrix multiplication is not commutative. So if you do some number calculation, 2 into 3 is always same as 3 into 2. But in case of matrix, AB is not equal, may or may not be equal to BA. Okay. So this, what I mean over here is that this is not commutative in nature. Okay. And one more thing from MATLAB, if you, let's say, if you have a matrix 1, 2, 3, 4, and this is 4, 5, 6, 7. In some application, let's say what you want to do is you want to multiply first element with the first element, second element with the second element. Let's say you want something like 4, 10, 18, 28, something like this you want. Then you can do this thing, that A dot into B. Then you will get this kind of answer. If you take place a dot just before this multiplication sign, then it does a element wise multiplication. Okay. Okay. Next two section I have sort of copied from Professor Gilbert Stein's lecture, but I actually like this way of multiplication, and it helps you, like if you are going for like if you are especially if you are a mathematics student and while attempting proofs or solving some question, this kind of help this understanding will help you probably. Okay, now we saw a way of multiplication where we were taking the first row and we were multiplying it with the first column to get the first element. But actually, what do we mean by matrix multiplication? This is what we have to understand over here. Okay, let's say we have a matrix A11, A12, A13, A21, A31, A22, A32, A. Okay, and we want to multiply it with, let's say C1, C2, and C3. Okay, what does this mean? We have to like this is what he explains in a very great way. What does this mean is you want to multiply C1 with the first column. Okay, so what you want to do is you want to multiply C1 with the first column, A21, A31. Then in this you want to add C2 multiplied with second column. Okay. Then you add C3 multiplied by third column. Okay. This is what is meant if you multiply any matrix with a column vector. Okay. So if you look at the answer, what you would get is C1 A11 plus C2 A12, okay, plus C3 A13. This is same if you would have gone the other way around also. So A1 in A11 into C1, A12 into C2, A11 into C3. But to beauty is to view this in this way, that you want to multiply first column with the first element. Okay. So this first column with the first element, second column with the second element, and third column with the third element, and you want to add all of them. Okay. This is what is meant by multiplication with a column vector. Okay. Now I'll go to what is meant by multiplication by a row. Okay. Let's say we have a same matrix. I'll probably borrow this from here. Somebody is joining now. Okay. Let's say we'll take 2 cross 2 only now. Okay. A11, A12, A21, A22. First of all, can we multiply it with a row C1, C2? So this is 2 cross 2. This is 1 cross 2. So we can't multiply. So post multiplying with a row is not possible. So multiplication by row would mean pre-multiplying it with some row. Now what is this? This is 1 cross 2. This is 2 cross 2. Now our size is compatible, so we can multiply this. Okay. So pre-multiplying with a row, what does this mean is, I'll just connect my charger. Yeah. So pre-multiplying by a row means you want to multiply first row with the first element, C1 into A11, A12 plus C2 into A1, A21, A22. This is what is meant by multiplication by a row. Okay. So this understanding has helped me solve many questions when I was appearing for JAM also, and later for NET also. This kind of this understanding helped me solve a question much faster than if I would have gone the traditional way. So you can just keep it in mind, it will help you, that's for sure. So for multiplication by a column, you say that the first entry is multiplied by the first column plus the second entry multiplied by the second column, third entry multiplied by the third column, and you add all them together. Similarly, if you pre-multiply by row, then it means that you are multiplying first entry by the first row, second entry by the second row, and then you add them together. Is it clear? Any doubt in this? Any doubt? Okay. Now, let's say we are multiplying two matrix. Now, I mentioned how to multiply by a column. I mentioned how to pre-multiply by a row. Let's say if we can extend this to multiplication of two row. Okay. Let's say over here, my first column is A1. Let's not write all the entries now. A2, A3. Okay. This is a 3 cross 3 matrix. So there are 3 rows which I have represented like this only. So this is my one column with 3 entries. A1 has 3 entry, A2 has 3 entry, A3 has 3 entries. Okay. I want to multiply this by B1, B2 and B3. Now, as I said, like if you want to multiply this thing by the first column, what you would get is B11 into A1, here A1 is the column, plus B12 into A2 plus B13 into A3. So the first entry of B1 multiplied by A1 plus second entry of B1 multiplied by A2 plus third entry of B1 multiplied by A3. You will get something like this. This you will get as the first column. So this would be corresponding to the, so let's call it C1. This you would get as the first column. Now, if you now multiply this matrix by the column B2, you will get the second column. And if you multiply it now with the third column, you will get the third column C3. So this is what is happening in matrix multiplication also. You can see this row wise also. So let's say this is our, let's say this is A11, A12, okay, A22, A21, A22, and you want to multiply it with something like B1, B2. Then our first row would be A11 into B1 plus A12 into B2. This is what I said. Now to obtain the second row, you can just do the same thing. A21 into B1 plus A22 into B2. So this is another view of matrix multiplications. You can see this. Any doubt in this? Okay. Now here is a small formula. Which portion, Mudit or Munish, which portion you want me to repeat? Okay. I'll take an example, right? I'll take an example. That would be more better. Let's say this is our matrix 1, 2, 3, 4, and we want to multiply it with, let's say 1, 1, 0, 1. Okay, we want to do this multiplication. Now, as I said, how to, let's say if we had just this much, 1, 2, 3, 4 and 1, comma 0. How would we multiply it? We will multiply 1 with the first column. Okay, so 1 into 1, comma 3, and then add to it 0 multiplied by the second column. Okay, so what we would obtain is this would be 1, 3 and 0, 0, and we'll add them. What we get? We get 1, comma 3. Okay, now how to get the second column over here? To obtain the second column, what we will do is we will multiply it like this: 1, 2, 3, 4. Then we'll multiply it with 1, comma 1. So this will give us 1 into 1, comma 3. This is 1, 3 plus 2, 4. What do we get? 3, 7. So second row would be 3, comma 7. Okay, this is what I meant. Now if we go to the row version, we'll just do the same multiplication in the row form also. Okay, I'll just copy this one only. Okay. So to do this, wait, yeah. To do this, what we want is, now we want to obtain our first row. Okay. So, wait. This first row over here can be obtained by this 1, 2, 1, 0, 1, 1. Now what does this mean? This is 1 into first row, 1 into first row plus 2 into second row. What is this? 1, 1 plus 0, 2. What does this give? 1, 3, right? And similarly for the second one also you can do. This would give you 3 and this one would be 7. So you can see we got the same answer. Yeah. Monish, is it clear to you? Yeah. Yeah. So now here is a small formulation which says that AB transpose. So A, if you multiply A and B first and then take its transpose, is equal to taking B transpose and then multiplying it with A transpose. I think sir said that you can have a look at it. So I have a lot of time. So I'll probably try to see it the way we discussed this multiplication right now. Okay. Okay. So now let's look at AB transpose and let's try to find first column of AB transpose. Okay. So we want to find first column of AB transpose. Now, first column of AB transpose is nothing but what it is? First row of AB, right? First row of AB. Now, how do we obtain first row of AB? So, if we wanted to obtain the first row of AB, what we would have done is, wait, what we would have done is that we would have taken the first row, okay, of A1, A, that is our first row of A, and multiplied it with B. This is what we would have done. Okay. So the first column of this is first row of A, yeah, multiplied by B. Now let's come the other way around. Okay. So we reached to a conclusion that this is first row of A multiplied by the complete B matrix. Okay. Now let's look at what is B transpose into A transpose. Okay. We want to see the first column, like if these two things are equal, these two things are equal, then their first column would also be equal. Let's look at first column of this quantity. So what would be the first quantity of this? This is B transpose, okay, multiplied by the first column of A transpose. First column of A transpose. Okay. Now what is our first column of A transpose? This is B transpose multiplied by first row of A. Now first row of A would look like something like this, but it is now written in vertical form. And like if you look at B transpose, now let's say it is B1, let's say our B is something like this, B11, B12, B21, B22. Then our B transpose is B11, B21, B, and then this is B12, B22. So multiplying this with its like B transpose with first row of A as column vector, what does this mean is this is multiplying. So let's say, okay, I'll take an example. I hope I am not clear here. Yeah. There are easier proofs to this, but I wanted to just approach it this way. Yeah. So let's say my first row of A is A11, A12. Okay. Now we are doing something like this, A11, A12. Okay. What would this give is A11 into B11, B12. Okay. This is A12 into B21 into B22, right? Now, if you look at this thing, this B11 and B12 was the first row of B. So, where we reached over here, so if we are multiplying first row of A with B, what we would have got? First element of this A11 into first row of B plus second element of this A12 into second row of B, and this is what the same we are getting in B transpose A transpose also. What does this mean? That both the entries are same. So column for both of them are same. So similarly, it can be proved for any arbitrary this thing also, that we are getting it to be same. Is it clear? Okay, thank you, Udit. Okay, now we will get to the main part why we focused on matrix till now. We want to solve a system of equations. Now we will solve many system of equation. We have 1 hour for that. Yeah. Let's say we have some system of equation like A1x1 plus A2x2 plus A3x3. Okay. Let's stick to 2-dimension right now. We'll move further later on. Okay. This is equal to some C1 A2x2 plus, sorry, A2x1. What am I doing? Sorry. So B1x1 plus B2x2 is equal to C2. So this is the system of equation that is given to us. What we want to do is, we want to convert this into a matrix notation. Okay. We will try to do that. What we will do is, we will take the first element from here and write it over here. Second element, and we'll write it over here. Okay. This is B1. This is B2. Then this is x1 into x2, which is equal to C1 into C2. You can see this like this. So if you look at this equation, this is nothing but x1 multiplied by A1 B1. So this first portion here, if you look this thing, this is same as this. So if you, in first row you have A1, you multiplied it with x1. In the second row you have B1, you multiplied with it x1 plus x2 into A2 B2. This is equal to C1 C2. And this is what I told you, like what matrix multiplication mean to us. So if you are multiplying this by a column x1 x2, a matrix A1 A, then first column gets multiplied by first element and second one multiplied by the second element. So you can see that this matrix multiplication that we have written, this A x is equal to C, is correct. Right? We can write this equation in this form. You can also do your normal matrix multiplication the way you used to do. You can see that A1 into x1 plus A2 into x2 is equal to C1. So this would give you the first equation if you multiplied it normally. Then B1 into x1 plus B2 into x2 is equal to C2. Right? So this is how we transform our like system of equation into matrix notation. Okay. Is this clear? Anybody has any doubt? How do we convert this? Yeah. Okay. Before we actually start solving, I'll give some motivation for row echelon form. And after that, we'll also see how do we go for row echelon form. And then we'll start solving this equation. Let's say you are given these two equations with you. first system of equation. First one is x plus y plus z is equal to 6, then 2x plus 3y plus 2z is equal to 14, and last one is x plus 2y plus 2z is equal to 11. Okay. So, and the second one is that I'll remove the 0, 0 terms. This is 0x, this is 0z, this is 0x. Which one appears to be simpler to solve for you? For me, the second one is much simpler. Yeah. So because I have y available over here, I know that my y is equal to 2. I can put it directly in my third equation and get z is 3. Then I know y and z, I can put it in 1, that x plus 5 is 6, so my x is 1. Here I would have to do elimination everything again and again. So what is this row echelon reduction? We try to convert our like system of equation into simpler form like this, so that after that we can just compute it directly from there on. Okay, so this is what we do in row echelon form. Now there are certain property when we call the matrix to be in row echelon form. So I'll draw an example first. So in the particular form of row echelon form that I'm talking, so first rule is all the 0 rows should be at bottom. Okay. So if you have any 0 rows, you should move them to the bottom. So you can replace 2 rows and move it to bottom. Okay. Let's say this was my 0 row. Okay. Next is, if you have like from start to top, if this is the first entry of any row, so if this is the first entry in any row, all the entries below that thing should be 0, below that thing. So for my first row, this was my first entry. So everything below this should be 0. So this kind of element is called as pivot element. The first non-zero entry in any row is called as the pivot element. First non-zero entry in any row is known as the pivot element. So anything below the pivot element is 0. Okay. And here we can have any random entries 3, 4, 5, let's say. Again, here also we can have 0, 1, 2. Okay. Next rule is that if you have, let's say, a pivot in first column over here in the first row, next row onwards, whenever you have a pivot element, that should be to the right of the previous pivot element. Okay. New pivot should be on right of previous pivot. Okay. So this is, let's say, a proper row echelon form matrix. So in this, you see the whatever pivot element I have, everything below that is 0. If I have any row with everything 0, those rows I have placed at bottom. Okay. And like the first non-zero entry in the first row is to the left of first non-zero entry in the second row. Or if it would have been over here also, then also it should be on the left side only. Okay. So this is a property of row echelon form. Okay. How do we reach to row echelon form? We reach to row echelon form by something called elementary row operation. Okay. If you have any doubt, you can stop me then and there, and you can either, yes, 1, 1, 1 are pivot in this example. So what is called, what is elementary row operation? There are 3 rules in elementary row operation. First one is you can exchange any two row. Exchange any two row. For example, let's say your matrix was something like 0, 0, 1, 2. Now how to, yeah. Anybody wants to speak something? Okay. So if you want to reach from here to your row echelon form, what you will do is you will exchange row 1 with row 2. So this is first row of our matrix. This is second row of our matrix. You will exchange these two. So what you will get is 1, 2, 0, 0. Okay. So this is a row echelon form. Now I'll take a big space. Now second rule is you can multiply any row with a non-zero scalar. So I'll come to this example again. Yeah. Third rule is you can add a row to any other row. Okay. Now let's take an example. Let's say we have 1, 2, 2, 3. We want to convert this particular matrix. Kritika, in row echelon form, your pivot can be negative. There is another form called row reduced echelon form. In that, you can't have your pivot to be negative. There, all the pivot should be 1. I'll come to that, but in row echelon form, you can have your pivot to be negative. In row reduced echelon form, you can't have. Okay. Okay, now when we look at this matrix, what is a rule for our row echelon form is that let's say we take this to be our pivot element, then anything below that should be 0. We want to convert this to be 0. Now, why did we write that we can multiply it with any non-zero entry is, like if we want to add -2 times of row 1 to row 2, this is same as multiplying row 1 with -2 first and then adding it. So this is same thing. That's why these two rules work sort of together. So you can also replace these two rules by, you can add or subtract any row to other row. So this also works. Okay. So if we take R2 to be R2 minus 2 times of our R1, what do we get? We get 1, 2, 0 and -1. This is our row echelon form. Okay. Now there is one more thing called row reduced echelon form. Okay, I'll come to this, and this is more used one. In row reduced echelon form, there are two more rules that are extra from row echelon form. First is every pivot element should be 1. Okay, so every element should be 1. Next is every entry above the pivot element must be 0. So this is like how we do. Okay. So let's say we take the previous example, we reached till this point 1, 2, 0, -1. Now if we look at the first rule, this pivot entry is -1. We want to make it to be 1. Not only positive, but we should make it as 1. How do? We multiply it with -1, second row. What do we get? We get 1, 2, 0, 1. The next rule says that everything above the pivot element should also be 0. Then what do we do is, we make this transformation. R1 goes to R1 minus 2 times of R2. Okay, so what do we obtain? 1, 0, 0, 1. This is the row reduced echelon form. So one more thing is that row echelon form are not unique. You can have more than one row echelon form depending on your mode. So if you decided to, after this step, you decided that you want to multiply the second row with 2, nobody can stop you, right? You can multiply it and you get 1, 2, 0, minus 2. This is also a valid row echelon form. But for row reduced echelon form, you will always get a unique form. So this is also an advantage of row reduced echelon form. So one more thing, when to use a row echelon form and when to use row reduced echelon form. So like when you're doing hand calculation, generally you reach to row echelon form first, and row reduced echelon form takes many more steps. So if you are doing hand calculation, you should use row echelon form only, and then you should solve those simple equations that you got. That would be easy for you. But if you are using the computer, so if you see this thing, so this would have given you, let's say x1, x2 was multiplied by this, and you got some, let's say d1, d2, then straight away you would have got value of x1 and x2 from here. Okay. So if you have a computer with you, you should go for row reduced echelon form. That would be beneficial for you. So for MATLAB, you can use the code RREF, the curl, this curl bracket, not curve, this is your normal bracket, and A, if you write the matrix name in it, you get the row reduced echelon form for that particular matrix. So A matrix that I wrote above, here I have obtained the row reduced echelon form for that matrix. Okay. Any doubt in these two, you can ask. I'll wait for a minute. Mudit don't have any doubt. Others. Okay. So, yeah, why did we study all these things is that we want to solve our system of linear equation. Okay. Now, let's say we have a very simple system of linear equation, x plus y is equal to 2, x plus 2y is equal to 3. Let's take a very simple example. Like if you would have solved it by elimination method, let's write its matrix, right? So this is 1, 1, 1, 2 into x, y. This will give us 2, 3. One simple way is you find the inverse of this matrix and you pre-multiply this side, you will get the answer. Yes, Nandu, you are correct. Row reduced echelon form is unique, but a row echelon form is not unique. Now, let's say we want to solve this simple equation. So if you would have gone by normal elimination method, what you would have done is, let's say this is equation 1, this is equation 2. So you would have done 2 minus 1 probably, and it would have given you x plus y is equal to 2 and y is equal to 1, right? Then you would have replaced this y over here to obtain x as also 1. You see that along with the coefficients, whatever operation we are doing, let's say we subtracted first row from the second row, then the same calculation was done also on the values that are on the right side of the equation. Okay. So if we want to solve this system of equation, so whatever operation we are doing, we should also do on the right side of the this equation equal to sign. So to do that in just one go, what we do is we form a augmented matrix. So in that, how do we form an augmented matrix? First matrix is your like the coefficient matrix. Then you augment to it the right hand side or the B matrix. If this is the equation of form X is equal to B, then you augment the B matrix. And now you treat this matrix to be a single matrix of this form 1, 1, 2, 1, 2, 3, and you do your elementary row operation to get the echelon form. Okay. Remember that the last column that you have is the right hand side of your system of equation. Okay, let's say we wanted to do this by row echelon form. Again, now we want to reduce it to row echelon form, right? So what we will do is we'll subtract this. This is same as the elimination method, but just in a matrix form. Now R2 goes to R2 minus R1. This will give you a matrix 1, 1, 2, 0, 1, 1. Okay, so you have got the row echelon form. So everything below this is 0 and the pivot element to the right, there is no more simplification needed. It is possible that you can subtract this thing, but it is not required. Now how to rewrite this as equation? So this first entry was corresponding to x, second was for y, and this is equal to 2 because this last column was your right hand side. Okay. Now for the second one, this is 0 plus y is equal to 1. You got the same thing that you got there also. So you can again put this over here and you get x is equal to 1. If you wanted to further reduce it to row reduced echelon form, what you would have done is R1 goes to R1 minus R2 because you want this entry to be 0. This is a pivot element. You want entry above it to be 0. Then what would you have got? 1, 0, 1, 0, 1, 1, right? Now if you reduce it to equation, what does this mean? X is equal to 1, y is equal to 1. So this is the advantage of row reduced echelon form, that you will straight away get the answers, but calculation takes one more step, one or two more steps. Okay. Any doubt in this? Okay. Now before I get to the next question, I think I missed the important thing. I'll cover that first. Okay. Now we are talking about system of equation. I'll switch to our matrix notation only. Let's say we have a system of equation given by Ax is equal to b. So Ax is equal to b means we have some equations on the left hand side equal to some coefficients on the right hand side. So this is of this form. So if my system of equation was this, we can write this as a, this as x, and this as b. Okay. So let's say we have a system of equation to be Ax is equal to b, or let's say of this form, ax plus ax1 plus bx, not, let's not take a1, wait, a11 x1 plus a12 x2 is equal to b1, a21 x1 plus a22 x2 is equal to b2. We have some system of equation. We can have more variables and all those things. Now, does the solution always exist for our system of equation? So the answer is clearly no. Okay. So there are three cases that would arise. So first we'll have two cases, that is solution exists. In this case we call this system to be consistent. If our solution exists, then we call it to be consistent system of equation. Okay. If solution does not exist, then we call it inconsistent. Okay. So if our solution does not exist, then we call it as inconsistent. Okay. Now, here also we can further divide it into two parts. Let's say our solution exists, then there are two possibilities. First one is that there is one unique solution. Okay. Second one is there are infinitely many solutions. So in linear algebra, or in when you solve system of linear equation, it won't be like there would be two solutions or three solutions. Either it would be a unique solution or there would be infinitely many solutions. Okay. So let's take a very simple example. Let's say we have again x plus y is equal to 1 and 2x plus 2y is equal to 3, let's say. Okay. Now let's use our normal elimination method. What would you get? And let's do matrix also side by side. So here we will have 1, 1, 2, 2, 1, 3. This is the augmented matrix that we'll get. And to solve this, what should we do? We should subtract the second equation. From second equation, we should subtract 2 times the first equation. Same thing over here in the matrix also. So what we will do is, we'll take R2 to be R2 minus 2R1. Okay. So what do we get? This is 1, 1, 1, 0, 0, 1. The equation you would have got x plus y is equal to 1, and this is 0, 0, 0 plus 0 is equal to 1. Now you see the second equation says that your 0 is equal to 1. Is that possible? That is not possible. Okay. So then this kind of system are called inconsistent system, that the solution does not exist. Now here also you can see that the second one would suggest that 0 is equal to 1. So whenever you have this kind of formation, then your system is inconsistent. Okay. Now let's take one more very small example, that is x plus y is equal to 1, 2x plus 2y is equal to 2. Let's do it by matrix now. I think all of you are familiar with matrix. This is 1, 1, 1, 2, 2, 2. Now if you want to reduce it to echelon form, what we will do is R2 goes to R2 minus 2 times R1. What we will get? This is 1, 1, 1, 0, 0, 0. Now you see that the second row is saying that 0 is equal to 0. This is correct. There is no issue with it. 0 is equal to 0. But we didn't got any information with, this is a consistent one, right? This is consistent. But we didn't get any extra information about y. Okay. So now we have only one equation left with us. That is x plus y is equal to 1. This is the case when we have infinitely many solutions. You can take any value of y. Based on that value of y, you will get some value of x. Let's say you took y is equal to a, then x would be 1 minus a, right? So you have infinitely many solutions in this case. You keep changing the a, you will keep getting the x. Let's say you took y is equal to 1, then your x is 0. You took y is equal to 0, then your x is 1, right? So this will form a straight line probably, right? So you have infinitely many solutions to this system of equation. Okay. See, if you want the exact condition, I can write it, but yeah. Let's say, okay. You row reduced the matrix, okay. This is your augmented matrix. This is A and B, okay. You have some entries over here. Balaji, I'm talking to you. Yeah. So in last row or in any row, okay, you have all the entries to be 0 except of the last one. Let's say this is 3, okay. Then that case, what does this mean is, because your last column is corresponding to the right hand side of the equation. So what does this mean is that 0 is equal to 3, which is never correct. So if you have any row such that all your entries just before the last entry is 0 and the last entry is non-zero, okay, in that case your system is inconsistent. Is this much clear, Balaji? Then I'll proceed further. Like when it is inconsistent. So
Yes, sir. Yes, sir.
yeah. Now what about infinitely many solution? Let's say you row reduced system of equation. Okay. and let's say you have n variables. Okay. Now, if you have, let's say, now n rows with pivot element. Okay. Let's say every of your row have pivot element. This is 1, 2, 3, 4, and some entries over here. And here you have B1, B2, right? Something. Now, if your every row, like number of there are n variables and your n rows have pivot element, then you will get information about all the n variables. In this case, your solution would be unique. For example, in our first case, when we solved this one, right? Here, see, so there were two variables x and y, and we had two pivot elements, 1 and 1, right? In that case, we had a unique solution that x is equal to 1 and y is equal to 1. So if your number of this variables matches the number of pivot elements, then you have unique solution. Okay. And if your number of pivot elements is strictly less than your number of variables, then you will have infinitely many solutions. So as in this case, in our example, see, we had two variables, but number of pivot element was only 1. So for the other variable, because we didn't had any condition on y, we had to choose it arbitrarily. Then we got infinitely many solutions. Is it clear, Balaji?
Yes, sir. Thank you, sir.
Okay, thank you. Okay, now this is our this question says the augmented matrix of linear system has been transformed by row operation into form below. So this is the augmented matrix, and they have already transformed it into a row echelon form for us. They're asking whether this is a consistent system or not, or an inconsistent system. What do you guys think? Please type it in the chat box. What do you think? This is consistent or inconsistent? Let's say our variables are x, y, and z. Okay. Then what does this last row says? This says that 5 times z is equal to 0. So is there any issue with this? If my 5 times z is 0, then what does this mean? That z is 0. There is no issue with it. So this system is consistent indeed. If we had something like 0, 0, 0, 5, then the system would have been inconsistent, Mudit and Manish. Because then we would have 0 is equal to 5, which is not correct. Yeah, that's fine. There is nothing to be sorry about. So 5z is 0 in this case. So we have solution existing for this. So this is a consistent solution. Okay, this was, let's, yeah, below pivot must be 0. So everything below pivot is 0. There is nothing below this, so no, not an issue. Is there something that I didn't understand, Monish, in your question? Okay. Now it is asking that for what value of h and k the following system is consistent. Okay, I'll solve this one for you. You all can solve, but yeah, I'll solve. So let's form the augmented matrix first of all. This is 2 minus 1 h minus 6 3 k. Now the first step should be, let's transform this. R2 goes to R2 plus 3 times of R1. What do we get? 2 minus 1 h. This is 0 because 2 times 3 is 6, minus 6 is 0. So this is minus 1, this will also get 0. This is h plus, sorry, this would be k plus 3h, right? Now, if we want our system to be consistent, because we got everything before the last column to be 0, this entry should also be 0, otherwise the system will become inconsistent. So we want k plus 3h to be 0. What does this mean? That my k should be minus 3 times of h. So this is the condition on h and k that will make the system consistent. Hope this is clear for everyone. Okay, you guys try this question. I'll also solve after you have tried. So I hope the font size is good enough for this to be visible to all. So you have a system of equation. It is asking for what values of A does the system have a unique solution. And then it is asking you to find the pair A comma B for which the system has more than one solution. So first of all, in both the cases, the system should be consistent because solution exists. You form the augmented matrix and try solving it, and let's see if all of your answer matches, then I will not solve this. I'll write I think all of you would have written at least the augmented matrix by now, so I will write it. 1A, 4, A, 9, and B. So now you need to row reduce this one. Like if you are done with even A part, you can write the answer in the chat box. So this would be R2 goes to A is a scalar, so I can multiply A into R1. This is, sorry, R2 minus A into R1. You will get something like 1. A times A is 0. This is A, this is 4. This is 9 minus A square. This is B minus 4A. Now, if you want unique solution, you want this entry to be non-zero. Because if this becomes 0, then there will be two cases. That this is also 0, then it is infinitely many solution. And if this is 0 and this is not 0, then it is inconsistent. So you want for unique solution this particular entry to be non-zero. So when is it non-zero? When is my 9 minus A square not equal to 0? Did you guys solve? When is 9 minus A square not equal to 0? So my A square should not be equal to 9. So A should not be equal to 3 or minus 3. Yeah, that's it. So this was A part. Now please solve B part. At least I need 5 to 6 people to solve that. It is saying that we want pair A comma B such that it has more than one solution. So for more than one solution, this particular entry should be 0. Then only you will have this complete. So if my second row completely becomes 0, then we have more than one solution, right? So my second entry should be 0 as well as this entry should be 0. So you need to find when it is true. So for what pair of A and B this thing is satisfied. I think you will get two pairs of A and B. I hope this is clear, like when do you have one solution, when you have more than one solution, when the system is inconsistent. If this is not clear, please, like if to anyone, if it is not clear, please type in the chat box. I'll be happy to explain it again. Okay, I'll try to solve for A is equal to 3. Somebody has solved. Mudit, you need to also find the value of B in such case so that this thing becomes 0. So now A should be plus minus 3. Okay. Now when my A is 3, then I want B minus 4A also to be 0. So my B is 4 times of A. So when my A is 3, B is 12. When A is minus 3, then my B is minus 12. Okay. So this is my pair. Monish got it correct. I think we have 15 minutes left. So some of you guys, I'm not sure whether these people are here, but you posted that there was some discrepancy with answers that in the assignment. Praveen, for all those solution would be uploaded automatically. So probably this week or end of this week, I'm not the assigned TA for that task. But whenever you take a NPTEL course, all the solution in proper format gets uploaded within 2 to 3 weeks. So you will get the solution. But for the questions that people raised concern in discussion forum, like I have included them, I'll cover that and then I'll go back to whatever I have prepared. Okay. So there was a question, like this was the matrix and it was asked to find the row echelon form for this. So what we can do is first step would be to like we want. So if you look at the options, in all the options we have 2, 3, minus 4, 2, 3, minus 4, 2, 3, 4 on the top. So we need to swap first and third row first of all. Okay, so we want to exchange these two rows. So what we get is 2, 3, minus 4, 1, 2, 2. Okay, and then it is yeah, this is 1, 1, 1. Now we want to make these entries 0. So we do two operations simultaneously. We take R2 goes to R2 minus half of R1 and we do over here R1, this I'll write here, R1 goes, sorry, R3 goes to R3 minus half of R1. Okay. So when we are taking half of 2, this entry becomes 2, 3 minus 4 only. This is 0. This is 3 by 2 minus 2. This is half. So this one becomes your, this, you are subtracting minus 2. So this becomes 4. You get 0 over here. You get minus 1 by 2 over here. You get, I think you will get, yeah, 3 over here. Okay. Now, when you add these two entries, now this is your next pivot element. You want to make this to be 0. So R3 goes to R3 plus R2. This makes it 2, 3 minus 4, 0 half, 4, 0, 0, 7. So this option matches exactly to what we have solved. But some people raised concern that this can also be a correct answer because this is multiplying this with -1. So this is correct, that this can also be answer. So here two options are correct, but I don't have any command over those checking of those assignments. I also don't know who is going to check them. So I can just say for your like learning that both the options are correct, but I can't change the answers to them. So for that you need to write in discussion forum only. Probably the concerned TA will look into it. The second question was similar, so I won't waste your time in row echelon form reduction. Probably I'll do something more interesting. So here also the answer that people were getting or I was getting was this, and this does not match any of the option that was given. So for seventh question also, the answer that was given to you is probably not correct. So in ninth question, I think there was a typo. The question should be for which value of k the system does not have a solution, and then your k is equal to -1 is the correct answer. If the system, the question remains as it is, like for what value of k does the following system have a solution, then all these three options, k is equal to 0, k is equal to 1, and k is equal to 2 is correct. Okay, so here also probably the concerned TA will look into it. So these were the doubts. I expected that you will post doubt from whatever you have tried and those kind of things, but it is first week, it is okay. Okay. So I'll solve one of them and I'll include this PDF. You can try, or even you can try from book. So let's say we have to solve the system of equation. This is same as we have been solving. So I'll solve one of them. So let's you guys also like write it on copy and pen and try to solve along with me. Okay, let's see who solves first. So the augmented matrix that you will get is something like 1, 2, -4, 2, 5, -9, 3, -2, 3, and this is 4, -10, 11. Okay. So the first operation that we can, I'll thinner the pen. Yeah. The first operation that we can do is, first operation that I'll do is R2 goes to R2 minus 2 times of R1, because I want every element below this to be 0. So I'll make this 0, make this 0. Okay. And also I want R3 going to R3 minus 3 times of R1. Okay. One thing that you should be cautious with is you should not make changes, like if I made a change in R2 here, then if you are making some change to R3, that should not involve R2 over here. Then you will be making simultaneous change and you would be making error. Okay. So this will become 1, 2, -4. First row remains intact. Okay. Second row becomes 0. If I multiply now 2 by 2 is 4. This becomes 1. This becomes -1. This becomes -2. Third row is 0. And this becomes -8. This becomes -15. And yeah, this one also becomes +12, right? 33. Oh no, 23 too. Right. Now this is my pivot element. I want this to be 0. So I'll add R3 goes to R3 plus 8 times of R2. So this is 1, 0, 0, 2, 1, -1, -4, -4, -2. This terms become 0. This is -7 plus 16. This you would get as 7. Okay. So what do you get? That your -7 times, I think this is Z here. Z is 7 from the last row. That means your Z is equal to -1. You put it here. This is y minus z is equal to minus 2, where z is minus 1. So this is y plus 1 is equal to minus 2. So y is minus 3. Then you can put it in the first equation to get the value of x, where it should be plus 15. Yeah, it will be plus 15. It will be plus 15. Then this becomes plus 7. Yeah, this becomes plus 7. And then your z becomes plus 1. Then y plus z is minus 2. Sorry, y minus z will remain to be minus 2. And this will be y minus 1. And y will become minus 1. Then you can solve it. Yeah. So this is how you approach a system of linear equation. Okay. So we are almost out of time. I would probably like to talk about, I'll stop the recording now.